Algebra 2, Unit 1, Day 5 notes. Let's get right into it. Today we start working with absolute value equations. Absolute value equations, as many of you will remember, look like a V. Okay? If we graph the parent function of the absolute value equation, which is just y equals the absolute value of x. Okay? Well, let's make a chart first. When x is -2, the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Okay, so let's graph it. Let's graph these points. We have -2, 2. We have -1, 1. We have 0, 0. We have +1, 1. We have +2, 2. So you have a V-shaped graph. You basically have a positive slope and a negative slope at all times.
Ms. Powell, dial extension 2703 now, please.
Okay. So let's take a look at some other examples of absolute value equations, but now let's compare them back to the parent function y equals the absolute value of x. So let's remember what this looks like. Remember where the vertex is. The vertex is the little point where your two sides meet, okay? That's called the vertex, all right? So with that in mind, we look at the absolute value of x, and now there's a +2. Now notice that the +2 is outside of the absolute value, okay? If it's outside of the absolute value, notice that that red line is up 2 units from the parent function, okay? This, put a different color here. The dashed line here that you already see in front of you, that is y equals absolute value of x. So the +2 made it move up 2. Now outside of the absolute value again, there's a -3. That -3, according to this graph, it looks like it made it move down 3 units. Right? So now, different. The +3 here is actually inside of the absolute value. Now, what's in the absolute value? There's an x. If it's in with the x-axis is left and right. Well, if it's in with the x, it's going to move it left and right. If you look at these two questions that we did, it was not inside with the x. It was outside. So it affected the y, which is up and down, right? So let's look at what this one did. If you look, you'll see that the parent function was actually moved 3 units to the left. So it's left by 3 units. So +3 in the absolute value brackets made it move to the left 3 units. Now there's a -2 inside of your absolute value brackets. So inside's going to either move left or right. Well, this one moved to the right. So the -2 caused us to go right 2 units. Okay, let's continue down our page. So here we have a couple of equations where the parent function is given to you. Okay, so this is the parent function y equals absolute value of x. It's already given to you. And you are now going to say, what would the graph look like if this were my equation? Well, there's a +3, and the +3 is outside of the absolute value. So outside means it's either going to be up or down. Well, it's a plus. It's going to go up 3 units. Okay, so each of these points, right, the vertex, up 3 units. Okay? This point right here, I'm going to go up 3 units. So the vertex was up 3, and then that other point was up 3. Okay, you take any of these points and you go up 3 units. And you take them all. So you're going to get that side of the vein. Then you go up 3 units from these points over here. So we're up 3, up 3, up 3. Okay, pretty close, right? So they took the parent function and they moved up 3 units with that plus 3. Okay. So now let's look. Now there's a -5, but the -5 is inside with the x. So with the x, it's either going to be left or right. So looking at the previous examples, minus means we're moving right. So this is going to be right 5 units. So the vertex moves right 5 units to there. And then we can take all these other points. This point can go right 5 units. It's going to be right here. Okay. So all of those points go that way. Now you take this side and you're going to move all of these points 5 units to the right. So it's going to be there and there. Just going to keep going. Okay. So you've moved right 5 units. That is a translation to the right. Next page. Now, the only difference between the ones that we just did, those questions, and these two have more than one transformation. Okay? So these two have adding and subtraction inside of the brackets with the absolute value, and then they also have outside of the brackets of the absolute value. So we're going to do 2 things to all of these points. We are going to have this -5 make them go right by 5 units. We'll go 5 to the right. And that +3, it's going to make them go 3 up. So this vertex, I'm going to go 5 right, and I'm going to go 3 up. 2, 3, I'm going to end up right there. Pretty close. Okay. Okay, so now I'm going to translate the other points. Okay, so 5 right and 3 up for each point. So I'm just going to go bingo, bingo, bingo. A little closer there. 1, 2, 3, 4. Yep. Good, and then we're going to go this way. Okay, so we went 5 to the right and up 3 based on the 5 to the right and up 3 in the equation. So now this next equation, let's go a different color. This one has a +2 inside with the x. So inside with the x, it's either going to be left or right. It's a plus, so we're going to go left this time. Fold this. Left 2 units. And the -3, it's outside, so it's not going to act on x. It's going to act on y. It's up or down. It's minus, it's going down. So down 2 units, 3 units. So 3 down. So we start at the origin and we move left 1, 2, and we move down 1, 2, 3, right there to that spot. Okay. I know that this slope here was a -1. Check this out. It went rise 1, run 1, rise 1, run 1. And it went both ways, rise 1, run 1, +1 this way, and -1 this way. rise 1, run 1, both ways. So now that we have the vertex, okay, now since there's still a 1 in front of the absolute value bracket, we're going to rise 1, run 1, big dot. Rise 1, run 1, big dot. Rise 1, run 1. Now in the other direction, rise 1, run to the left 1, rise 1, run 1, rise 1, run 1. Okay, great. Okay. So there is our absolute value function that is moved left 2 and down 3 units. Okay. So to summarize what we should have learned from this, we look down here at the summary, and we're going to say that when we have a plus h, which means that inside of the absolute value, we have x plus a number. It's like x plus 2, okay? If there is a plus, okay? So if h has a plus, right, I'll just write h is positive. That means we are moving left h units, okay? We're going to move left h units. If inside with the x, inside the absolute values, there's a minus, so like x minus 2, for example. If h is negative, so if it's x minus 2, so if it looks like this, x minus 2. And the first one, it would look like this, like x plus 2. Okay. And that means if there's a minus, we go to the right. H units. Okay, so we go right H units with minus, we go left H units with plus. Again, that's when we're inside of the absolute value brackets with the x. Now k, if there's an absolute value and we have, say, plus 2 on the outside, okay? So that means if k is positive and we got a plus out there, then we are going up k units. If there's an absolute value bracket and then there's a minus anything, okay, a minus k, okay, so if k is negative, then your vertex is moving down k units. Okay, let's go to the next page, shall we? So our last page, we're adding a coefficient or a number in front for our absolute value. Okay? So the ones before that we just did didn't have these numbers in front. So we're just going to look at that and say, well, if those numbers are there, what's happening? What is going on with my graph? Okay, so we'll take a look at this. This one has a positive 2. Okay, and remember, this was the absolute value of x. This was just the parent function here. Okay, and it's the dashed one in each of these. Okay. So what did it do with the 2? The 2 actually, check this out. If you remember back in Algebra 1, the slope of a line, okay? Slope of 0 was horizontal, and then the further from 0 you got, the steeper it went. Well, this right here had a slope of 1. Your original had a slope of -1 coming in and +1 coming out. That 2 makes both of them steeper. Okay, so we've got a -2 coming in and a +2 coming out. So what that does is it makes the graph more narrow, okay? because it takes the slopes and brings them up closer to vertical. Right? It makes them steeper. When both slopes are steeper, your V in the absolute value narrows, whether it's up or down. It narrows out like that. Okay? Now, a 1/2, however, when the slope got closer to 0, okay, instead of a 1, it's a 1/2. So check this out. This actually is less steep. Less steep. So that 1/2, we went rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2. So we are rising and running so that the slope is a 1/2 and a negative a 1/2, which means they're flatter. So if you have two flatter sides, that means you are making your graph wider. Okay? So that 1/2 makes it wider. The +2 made it narrower. Okay? You can put the there. Now, look at this. There's a -3. Okay, this is kind of important. The 3 makes it narrower, just like the 2 did. Okay, so this one right here, that graph is narrower than your parent function. The 3 makes it narrower. But the negative all by itself, the negative does something. The negative reflects the original over the x-axis. It flips it, okay? So it reflects over the x-axis, okay? So you took your original, you flipped it with the negative, but then the 3 made it narrow. Okay, that's what happened there. Okay, so the conclusions that we've already kind of said for this. If A is positive, if the coefficient is positive, then we're opening up. Okay, it's one of these. If the A is negative, like this guy, we're opening down. We are opening down. Okay, it opened down. As the coefficient gets closer to 0, like we went from 1 to 1/2, okay, what happened? It got wider. Okay, you could also say less narrow. Okay, as the coefficient gets farther from 0, that's when the two sides of the absolute value get closer to vertical, and that makes narrower. Okay, it gets it more narrow. So that makes the graph narrower, or you could just write more narrow or less wide. Okay, we're good? Okay, let's finish it. This is a nice little exercise for you, okay? You might want to do this when you're getting ready for a quiz or a test. Go back here, maybe cover this part up and just ask yourself if you know how to answer these. Okay? So this first row, we're just going to state whether the graph opens up or down. So all we're going to look at is the coefficient. Coefficient, the coefficient, the coefficient, the coefficient. Okay? Opening up or down is based on positive or negative coefficient. So first one is negative, so that's down. Second one is negative, down. Third one's positive, up. Fourth one's negative, down. Okay. The widest graph. So remember, the widest graph is the one where the coefficient is closest to 0. So this is -1, this is -2, this is 1/4, and this is -1/3. Which of those four numbers is closest to 0? Well, 1/4 is the smallest of those numbers as far as distance from 0. So, boom, this one right here.
Mike, you may call 2701, please. Mike, 2701.
Sweet. And now finally, the narrowest graph. Narrowest graph means that the slope or the coefficient is going to be furthest from 0. So -1, -2, 1/4, or -1/3. Furthest from 0 would be a -2. Easy enough. That's going to be the narrowest of the four graphs if those four equations were graphed out. Sweet. Okay. We're going to graph these. Let's do it. We could do this a number of ways. I'm going to walk you through this without a calculator. This is how I would do it. Okay. First off, any plus or minus, I'm going to use the pluses and minuses to set my vertex. It's the only minus we have. -5. It's outside the absolute value brackets. It goes down. So that means I'm going to take my vertex, which was at 0, 0 right there, and I'm going to go down 5 units. Okay. Now I'm going to look at my leading coefficient. It's a positive, so I know I'm going up. Okay, it's open up. And it's 2. Check this out. This is fun. Okay, 2 is 2/1. From my vertex, I'm going to rise up 2, and then I'm going to run 1 both ways. Both ways. Get my light on here. There we go. Okay. From those 2 red dots I just made, the 2 big ones, I'm going to rise 2 and run 1 again. 1, 2, and a big 1. 1, 2, and a big 1. Okay. I'll do it one more time. 1, 2, and a big 1. 1, 2, and a big 1. So let's connect those dots. Okay, and you can see what you did. You started with the little dashed line, which is your y equals absolute value of x that had a 1 in front of it that you just didn't write. You went down 5 units with the -5. And then this 2 made it narrower. Okay. Last one. All the pluses and minuses. Okay. Step 1. Take the pluses and minuses. Okay. Step 1. Take the pluses and the minuses. Okay. Which lead me to my vertex. There's only one plus. It's inside the absolute values, and it's a +4. That means we're going left 4. So I start with my 0, 0, and I go left 4 units. 1, 2, 3, 4. I start right there. That's my vertex. Now, what's the coefficient? It's negative. So invisible math, -1. Okay, -1. The coefficient is -1. That negative tells me going down. It's going to be opening down. Okay, 1/1 going down. Check it out. Look how easy this is going to be for us. Starting at this vertex that I have, I'm going to go rise 1 in a downward direction, run 1. Big dot. Okay, back here, rise -1, run big 1. Okay, from those 2 bigger dots, rise, run 1/1, rise, run 1/1, rise, run, rise, run. Okay. So my second step after I did the vertex, I looked for direction to go if I'm going up or down. And then my last step, number 3, was I did the rise run. Okay, so those are my 3 steps to graphing all of these. Step 1, look for the plus minus. If there are any plus minuses in there, if you're adding or subtracting, okay, this negative is not a plus minus, it's a negative. Okay. Step 2, look at the coefficient, you see the direction. That's the way I'm going. I'm going down for my rising. If it's positive, I'm going up for my rising. And then I make sure I have a fraction and I rise over run. That's how I graph these without a calculator. Okay. Notice that we did not make this wider. It's the same width. We moved it left 4 units and we reflected it. We flipped it. Okay. That's all we did. Okay. We're done. See ya.